Hello and welcome to Regeneration Realized. For this benchmark, we are going to look at bulk density, why it's important, and how to do it.
Bulk density is a measure of the dry weight of the soil of a known volume. It's a great way to monitor soil compaction either at home or by sending samples to a lab. The higher the bulk density, the more soil is compacted into a unit of space and the less pore space there is for air, water, microbes, and plant roots to move around in. With bulk density, lower is better. Bulk density affects several ecological processes, including the water cycle, nutrient cycle, and community dynamic processes. Ideal soil will be roughly 50% empty space that is filled by air or water. This provides plenty of room for soil microbes to move around in and gives roots the opportunity to grow free of restriction with access to adequate nutrients and water. To get a representative sampling across your field, pick 3 subsample sites where you'll take the soil cores. If following the RU protocols, sample from subsample sites 3, 6, and 9. At each subsample site, take a picture with the GPS turned on, noting the direction of north. Record the field location and any other pertinent information. Keeping a photographic record not only helps you relocate your exact sampling locations, but it also helps you remember site conditions and identify factors that may have influenced your results. Sometimes soil compaction can vary greatly within the top 6 inches of soil in a field. To account for this, in fields where we encounter compaction, such as 300 psi in the top 6 inches, determined by using a penetrometer, we suggest collecting 2 separate samples, one from 0 to 3 inches depth, and the other directly below at 3 to 6 inches. If compaction isn't an issue, collect a single sample from 0 to 6 inches. If you do not have a penetrometer or are unsure about whether or not compaction may be an issue, consider collecting 2 separate samples the first time you sample a new field. Your bulk density results will help you identify if there are compaction issues and can be used as a basis for whether you take 1 or 2 samples in the future.
For this test, you will need, depending on the compaction, you will need either the 3-inch high or the 6-inch high. You will need your bags that you're using. So 3 bags for 6-inch if you're doing the full 0 to 6 inch on your bulk density. And if you're doing 0 to 3 and 3 to 6, you will need 6 bags for that. You will need a piece of wood or a 2x4. You will need a trowel or a shovel to dig out your cylinders, and a hammer or a mallet to do it. For this field, we've discovered that from 0 to 6 inches, we're underneath the 300 psi on our penetrometer. So we'll be using this 2-inch diameter by 6-inch high cylinder, and we'll make sure we get it in here, and we'll take our block of wood and we will get our full cylinder in there. So most important is to make sure that the entire cylinder goes in. We don't want gaps in that cylinder. And we'll carry on until we get the full cylinder into the ground. And you can see here, we're getting in there. We need a little bit more. We just want to make sure that is fully covered. And from there, we're going to dig this cylinder out. We're going to make sure it's level. So we'll take our trowel or our shovel and we'll start digging around. If you need to use the 3-inch high cylinder, you will dig out the first 3 inches. And then you will carry on and get a second one for that 3 to 6 inches. So because we're dealing with some loose soil here, we'll have to be really careful getting that cylinder out. We can often, just takes a little bit of doing. Just carry on until we can free it up. Okay. Now you may need to get underneath. We want to make sure that it is totally full. If it's not full, when the lab gets this, they will not be able to give you an accurate idea of what's going on. Now, if you need to, you can temporarily put it in the bag with the cylinder, and you may need to dig it out. So carefully dig it out with a screwdriver or a knife or some kind of device, and from there you can send it to your lab.
If you use the 6-inch tube, you will have 3 samples. If you use the 3-inch tube, you will have 6 samples. 3 from 0 to 3 inches, and 3 from 3 to 6 inches. Ensure that each bag is properly labeled. If you're shipping your samples to a lab for analysis, we recommend you add the following to your bag: bulk density, farm name, legal land description, sample depth, sample ID, and best, worst, or unmanaged if following RU protocols. Ensure your lab paperwork is properly filled out before shipping. Calculating bulk density is also very easy to do at home. Instead of shipping your samples off to the lab, do the following. Spread out each sample on a piece of cardboard, such as the bottom of a box with no holes or cracks, or a cookie sheet. Make sure to include the label with each sample. Leave the sample to dry in a safe area where it's unlikely to be knocked over and there's no wind to blow it away. Let the sample air dry until there is no moisture left. Usually this will take a few days. If you're really keen, samples can be placed on a cookie sheet in the oven on low temperature. Once the sample is dry, weigh it as precisely as possible using a kitchen scale or similar. Now you have your soil weight. To figure out your volume, measure the inside diameter of the metal sleeve you used to take the sample. Also measure the exact height of the same sleeve, such as the 3 or 6 inches in our example. Now do a bit of math. Diameter divided by 2 times pi times height of cylinder. To calculate bulk density, just divide weight by volume. But make sure you're using imperial or metric. Don't mix up your grams with your inches. And that's it. Now you've done it.